Thank you, Eddie from Illinois. Jessica van Puttkamer of NASA.
Yeah, let me give that a try. Any of you can, of course, jump in and correct me. Well, Voyager, for the last 12 years, has been an exercise in maneuvering, in navigating, and particularly in gravity assist maneuvers. We have been using flybys of Jupiter, of Saturn, Uranus, and now Neptune to change the trajectory to where we wanted it to go and to change its velocity. By flying by Neptune the way we are doing, or we just did a few minutes ago, we brought Voyager close to Triton tomorrow. So it's going to pass behind Triton, and it has to be behind Triton for us to be able to receive the radio signals through the Triton atmosphere, which we need to do to probe the atmosphere. But Triton is such a small moon that it cannot further assist us with turning the trajectory of Voyager 2. Voyager 2 is essentially headed out of the solar system whether we want it or not. We don't have any propellants on board left to change it with a propulsive maneuver, and there is no big mass center around anymore to help us. So Voyager 2 has been going out for many years now, and there's nothing we can change about that.
What is the next stop, Jessica?
There is no next stop.
Well, I mean, what will the next celestial body
Well,
be?
First of all, we need to become very aware, and we need to really imagine what infinity means. These Voyagers are really going into infinity of time and space. It's very likely that they will never, I mean, if you really can say never, for millions and millions and millions of years, encounter any other star close enough for decaying. But we will be passing by a lot of stars. For example, in the year 8571 AD, we'll be going by Barnard's star. But the passage, the distance of flyby is in the order of 4 light years. And then,
Mike Weilbacher from the Franklin Institute has a comment.
And then after it goes past Barnard's star in 8571, in the year 2031-9, it'll do its closest approach to Proxima Centauri, and it'll keep going, and it'll enter the Oort cloud in the year 2626-2.
I guess you need to explain what the Oort cloud is.
Yes, I think we do. I will come back to that in a second, but someone calculated where it's going to go. It's wonderful. It has it as far as the year 957963, where it goes its closest approach to the star DM plus 271311. So it's within 6.6 light years of that one. So it's going to keep on.
I think that it sounds ludicrous, but we really have to take a serious thought about it, because this is really the impact. That's the meaning of Voyager. Mm-hmm. If we just look at the hardware and if we are just amazed about the pictures, we are missing the real meaning of what's happening right now. Of an artifact from Earth, something made, built, figured out by humans, leaving the solar system out into eternity. That's something which
We should also point out that the happy accident that allowed Voyager to do the alignment of the planets that allowed Voyager to do this journey all the way as far as Neptune, that alignment was once every 175 years, something like that. Yeah. So it was a happy accident that got us that far.
I hope we answered the telephone call properly.
I think it was very complete. Okay. Thank you. Joyce?
Well, one other thing before Voyager gets anywhere near these close stars, it's going to be doing something else very important for us. It may help us to find out exactly where the heliopause is, and that's the edge of our solar system. That may be helpful to know.
And it's called the heliopause, the edge of the solar system. How would that be identified? And
well, I'm not exactly sure which instruments we're going to be using.
Out?
It's effects of the sun, like the plasma effects from the sun, and where the very edge is, where the sun no longer has any effect or bearing at all on anything that's there, and they enter interplanetary space.
All right, we're going to take a call now from Kent in Arkansas.